class, I got an email request from a couple of you for some additional examples of mathematical induction. So I have 3 more examples in this video. The correct proofs are typed up and included in the PowerPoint, so you can check your answers or look back on them for review. So, friendly reminder that the principle of mathematical induction, it involves us supposing that we have a function that's true for the propositional step, so for when n equals 1, and then we need to prove that if it's true for s equals k, which is our assumption, not s equals k, s of k, this is our assumption, then it also is true for s of k plus 1, okay, where k is any natural number greater than 1. So we need to prove first our basis step and then do this induction step. And we're going to do that for every single example that I have in this PowerPoint. So without further ado, prove that for every odd number to the n minus 1, we have, as long as n is greater than or equal to 1, we have 1, 3, 5. If I add to the n minus 1, like plus that, that's going to give me n squared. Now this might be kind of hard to see, so let's check it out. So if n equals 1, I would have 1 equals 1 squared, which is true, okay? And if you want, you can check this for when n is 2, right? If I have 1 plus 3, that's 2 squared, so 4 is 4. Okay, it seems like this is going to be true. So since 1 equals 1 squared is true, the statement is true for this statement is true for s of 1. So now we assume s of k is true for some k that's a positive integer or a natural number, right? We must show that s of k plus 1 is true, and that we find 1 plus 3 plus 5 plus ... 2k plus 1 minus 1 equals k plus 1 squared. So I'm going to go ahead and show you what k plus 1 squared is, right? K plus 1 squared, if we FOIL this out, this gives me k plus 1 times k plus 1, and that's going to give me 2k. Nope, it's not. Well, it is, but it's going to give me k squared first. So k times k is k squared plus 2k plus 1. So that could also be what my final step looks like. So I'm going to take if s of k is true for some k equals 2, oh, I skipped a step. So I need to find 1 plus 3 plus 5 plus 2k minus 1 equals k squared. So this is the step I take first, right? So now I have 1 plus 3 plus 5 plus 2k minus 1 equals k squared. And what I have to do next is I'm going to add 2 times k plus 1 minus 1 to both sides. So I'm going to have 1 plus 3 plus 5, which remember I told you didn't have to rewrite the whole thing, you could just use parentheses. Plus plus 2k minus 1 plus 2 times k plus 1 minus 1 equals k squared plus 2 times k plus 1 minus 1. And we should go ahead and simplify this right-hand side. So I get that all of this equals k squared plus 2k plus 2 minus 1, which equals k squared plus 2k plus 1, which is what I was hoping to get. So as desired. I don't think he's done it yet in this text, but when I took a proof class from him, he always ended his proofs QED, which you might see in that proof and reasoning additional reference I posted for you guys. And that means quo era deristratum. I don't know why I can't pronounce it today. And it means, thus I have shown. Oof. Okay, let's take a look at another example. Here is the solution all typed out. I hate it for you guys to wait, and then you can check your answers and see a little more clearly step by step. It's important to remember that I say it's true for k, and I use that to prove that it's true for k plus 1.